Hello everyone, welcome back to Tanisha's Concept Corner. We will be doing mathematics today. Chapter 3 Matrices. So, as we can see over here, there is definition given. Matrix, plural will be matrices. So, a matrix is an ordered rectangular array of numbers or functions. The numbers of functions are called the elements or entries of a matrix. So, generally, in a rectangular array, like in square brackets, in some books, you can see circular brackets also, that is also fine. So, this is how you represent a matrix. Generally, you need to use a capital letter is equal to square brackets, and in terms of rows and columns, either you can use numbers or functions like cos theta, sin theta. Those functions also can be written, and these numbers or functions will be called as entries or elements. So A has 3 rows and 2 columns. Horizontally, if you see, those are rows, and vertically they will be columns. So this is the first row, second row, and third row. This is the first column and then the second column. So similarly here, first, second, third row, and 1, 2, 3 columns. And this is having 2 rows and 1, 2, 3 columns. Now, order of a matrix. What is order of a matrix? You read it as M by N matrix. Nothing but M denotes number of rows and N denotes number of columns. And when you multiply these both M and N, that is number of rows and number of columns, you get the total number of elements or entries in your matrix. So this is a standard form of writing. Always remember, first will be number of rows only. M will be number of rows, N will be number of columns. So this is very important. Whenever you're writing a matrix in a, you will write it in a square bracket, you will fill it with the elements, and then here you will mention the order of a matrix, M into N. If you're going to multiply those values, you get the total number of elements. Always the first number should be number of rows. So this is how we are going to denote them. Generally, we are always denoting element in a matrix as A, I, and J. So this I is nothing but the row, which row it is, and J is nothing but which column it is. So if I just write a matrix, suppose 2, 3, 4, and 5. In square brackets I have written, and I have to write M into N over here. That is the order of matrix. Here I am having 2 rows and 2 columns. Now if I have to represent this element in a general form, I can write it as A. What is I? I is which row it is. This is the first row, so 1. J is which column it is. It's the first column, so 1 again. Now if you want to represent 3, same thing. A, it's still the first row, but now it is the second column. This is the first column, this is the second column. Look vertically. Now come to 4. How do you represent that? A, now this is the second row. In terms of rows, this is the first, this is the second. In columns, this is the first and this is the second. So you can simply write second row, and this is the first column. Second row, first column, you get 4. Then finally the final element you will represent it as, this is second row and second column. This is the representation, general representation. That is what they have written over here, except that they have just continued without specifying the number of rows and number of columns. So over here you can see this is first column, second column, third column, like that it will continue till N, because N is the total number of columns. Maximum will be what? That one only. If I wrote 2 cross 2 over here, this is the maximum number of columns. So the last column will be what? It is 2 only. I will write 2 only here. So instead of writing 2, they have just written n. They have just written n. Same thing with the rows. First row, second row, third row, like that fourth row, it will keep on continuing till what? Till mth row, because that is the total number. Here also same thing. 2 is the number of rows. So maximum what? What will be the last row? That will be nothing but 2 only. Here also see 2, 1, 2, 2. Like that it will be continuing. So that's what they have written. Instead of 2, because here you don't know how many rows are there, you're just representing with m. Then m1, m2, m3 till mn. This will be the last element. So this is the general representation, and I, as we represent any element like aij, the i's maximum range will be from 1 to m. That's it. No, if you want a matrix, obviously at least one row should be there, and then it will be till total number of rows. So one row to till total number of rows. This will be whatever value it can take up. It can be 2 rows, 3 rows. So that will be m. So that will be the range for a given matrix. I value till where can it go? 1 to m. Like if you see here also, till where the I range can go. You can see here 1 and 2. So it's between 1 and 2. One row is obviously there, and maximum number of rows are 2. This is nothing but my m. So it is ranging between 1 to m. Same thing for number of columns. So j is nothing but representing that columns. It will also be one column will be there, and till how many columns can this be, like how many values can j take? Till total number of columns it can take, and that is nothing but n. So always remember, I and j ranges for a given matrix will always be between 1 to m for I. For j it will be from 1 to n, and m and n values you can get to know from looking at the matrix. They will be giving you how many rows and how many columns will be there. So this is how notation we will follow. Generally, if you want to write any matrix, put square brackets, write the elements, write the order, and always put a capital letter over here. Then we shall consider only those matrices whose elements are real numbers or functions. So our elements, whatever you're going to fill here, it should either be a real number, otherwise it can be any functions, as we have already known. Sin x, cos x, all those functions can also come up over here. And generally some imaginary numbers can also be there, like only real numbers are allowed. There is no rule like that. Complex numbers also can be written, but for our level we are only dealing with real numbers and functions. Now see, if 0 and 1 is there, how they have represented this. Like this is one row and this is the other row, but there is only one column. So 2 rows and 1 column. And over here you can see there is only one row, but vertical if you see there are 2 columns. So the interchanging of that rows and columns makes a lot of difference. So we have to always keep in mind m cross n is not equal to n cross m over here in representation. While multiplying to find the number of elements, it is still fine. Here number of elements is same, but the order is changing. Here 2 rows and 1 column, here 1 row and 2 columns. So that will change. So be careful while writing here. First the number of rows, 2 into 1. Here you will write 1 into 2. So though number of elements is 2 only, you have to be careful while writing m cross n. Now example 1 is given. They are telling us to they have given like men workers, then women workers, and they are telling us to write a matrix in form of 3 cross 2. So they want 3 rows and 2 columns. So you can simply put this all in square brackets and write 3 cross 2 down. That is the standard way of writing, because here already 3 rows and 2 columns are there. So same thing. You can simply put the square brackets, 3 rows and 2 columns, and here you have to mention 3 cross 2 below, because generally standard way of writing is m cross n over here. So this they have told the second column is for women, and then the first column will be for men workers, and the entry in the third row and second column represents the number of women workers. Third row, second column, the number of women workers it will completely represent. So they are writing this statement because here actually they have given, like, you call this as index generally. So factory 1, factory 2, factory 3, and we are not generally representing them in matrix, so they have just written in a statement saying that if there is third row second column, it is showing the number of women workers in factory 3, because this is women columns and this last row is actually third factory, so you can just mention that statement. Now, this is an important question. If a matrix has 8 elements, what are the possible orders it can have? Order is what? M cross N. Now, it can be different. I'm saying again, number of elements can be same, but again, different matrices you can draw only because of order keeps changing. So, simply all you have to do is write the factors of it. 8 factors, 1 into 8, 8 into 1, though it is same in multiplication, but still this means 1 row and 8 columns, and this means 8 rows and 1 column. So change will happen. So write all the factors and all the possible pairs. So here 4 2s are 8. You cannot just say okay 4 into 2, 2 into 4 is the same thing. Why are we writing it again? Because here it's changing. This is 4 rows and 2 columns. Here 2 rows and 4 columns. So it will change off. So write every possible pair. First find the factors, write every possible pair, and you can just count what are the possible orders it can have. How many, if they ask, you can count and write 4 orders are possible. Now they are asking us to construct a 3 into 2 matrix whose elements are given by this. Now this is a general form of representing the element, and they have simply given in this format. So first thing to do is write it in this format for our own convenience. A capital letter is equal to, now they have already told 3 rows, 2 columns, 2 columns. Just follow that. They told to write a matrix, so capital letter is equal to square brackets. They told 3 rows and 2 columns. So just first fill it up in this way so that you get 3 rows and 2 columns. Close the square bracket, and now you can start writing positions. This is the first row, first column. This is the first row, second column. This is the second row, first column, second row, second column, third row, first column, third row, and second column. This is how it is. Now you got to know ij values for all the elements. So first you find out the first element. I value is 1, j value is 1. And they've given you this. So for first element, I value is 1, j value will be 1. So 1 minus 3 into half. Right? 1 minus 3 into 1 into half. 3 into 1 is 3. 1 minus 3 will be minus 2, but it is inside the modulus. So it will be positive only. So 2 by 2 will be 1. So our first element we got to know, that is 1. Now go to second element. What is the I value here? 1. What is the j value here? 2. So 1 minus 3 into 2 and then into half. Again 6 minus 1, 5. 5 by 2. No need to put the negative sign because it's in the mod. Again same thing. I value is 2 and j value is 1, and 2 minus 3 minus 1 inside the mod, so cancel out the minus symbol, and then you get 1 by 2. Then for the next element, 2 is I, again 2 is j, so 2 minus 3 into 2, 6 minus 2, 3 2s are 6, 6 minus 2 is 4, 4 by 2 will be again 2. No need to care for the negative sign, it's inside the mod. Then same thing, 3 minus 3 into 1, it is 0, 0 by 2 will be 0. 3 minus 3 into 2, 6 minus 3, again 3 by 2. So now you have to write all these in simply these positions. You found out their values, so put it in their positions, and you can write m cross n again here if you want to write 3 rows and 2 columns, 3 into 2. This is how you solve it. Now there are various types of matrices. Number 1 is column matrix. Column matrix is just that it has one column. Okay, we don't care about whatever the rows is there, whatever it may be, whatever the elements may be. If you got a matrix and you found out that it only has one column, then done. It is a column matrix. So the general form will always be m into 1. Because n you don't have to write, you know n is always going to be 1 if it is a column matrix. So that's why here 4 rows are there. Sometimes 5 rows can be there, 6 rows can be there. Many rows can be keep on increasing, but only one column will be there. So generally you will write a element aij, then to write the order, rows can be anything, but my column should be only one. So that will be a column matrix. Similarly, there is a row matrix where one row should be there. So 1 into n. Columns can be anything. Here 1, 2, 3, 4 columns are there. Columns can be n number of columns, but row will be always 1. Here they are representing by bij. Any letter you can use to represent it. This is a row matrix. Square matrix, one more important one. Square matrix is when number of rows are equal to number of columns. That means m will be equal to n. So you can just write m cross m or n cross n. Both of them should have the same letter. And here also you see 1, 2, 3 rows are there. 1, 2, 3 columns are there. So square matrix of order 3. M is equal to n, 3 rows and 3 columns. This will be called a square matrix. For diagonal matrix, it is like a type of square matrix, you can say. For diagonal matrix, what should be there? Always remember, as soon as you see a matrix and if they ask if it is diagonal or matrix or not, it should be a square matrix. So here you can see number of rows is always equal to number of columns. This is also a square matrix only. One row, one column. One row and one column. So m and n both are 1. So obviously rows are equal to columns. So this is also a square matrix. This is also a square matrix. 2 rows and 2 columns. 3 rows and 3 columns. So all these are square matrix, but diagonal matrix is like a special type in that square matrix. What is that special type? Only diagonally if you see elements will be there. Rest all will be 0. Here there is nothing like diagonal or not or nothing. Only one element is there. So you can consider it as diagonal matrix. But over here, you can say that square matrix with only one element, all of them will be diagonal matrix. Here, if you see diagonally, okay, there are numbers, but rest all the other elements are 0. Diagonally, if you consider, numbers are there, non-zero numbers, but rest everything are 0. So that is what they have written over here. When I is not equal to j, it should be 0. Okay, if you see this position, it is A11, first row and first column. So I is equal to j. If I is equal to j, it should not be 0. It should be some non-zero number. You can think it in this manner. A, I, j will not be 0. It will be some non-zero number k, let's think, when I will be equal to j. But if I is not equal to j, then your element will be equal to 0. Now see this matrix only, for example, first row, first column, I is equal to j. So should it be equal to 0? No, it should be some or the other number. It should be some or the other number. 2 should be there. Next, here I is not equal to j. So this should be 0. 2 and 1. Still, they are not equal. So it should be 0. Again, 2 and 2. Actually, this is here one more column we should have to add because this is actually not a square matrix. But just to understand I and j values, I have taken this example. Again, for here 2 and 2, I is equal to j. So it should not be 0. It should be some or the other non-zero number. Then here I and j values are not equal. These will be 0. This is not a square matrix. So just add one more column. Then what will happen to this element over here? It will be third row and third column. So here also I and j values are equal. So here also some other number might come. So this will form a diagonal over here. So that is what they mean to say. Whenever I and j values are not equal, put 0. Except the diagonal ones, all the other elements will be 0. Diagonal matrix. Now scalar matrix also is the same thing. It's just that I just said any non-zero number for diagonal. Here same number should be repeating. Same thing. Again, I is not equal to j, meaning it should be 0. All these places it is not. If I is equal to j, it is basically the diagonal elements, they should be equal to k, that is constant. If you're writing root 3, all these things will be root 3 only, all these things will be minus 1 only. And this can be again just because only one element is there, and again one row one column, so it is a square. For scalar matrix also it should be a square matrix, because we are talking about diagonal, it will be only possible if there is a square matrix. And here also any one element is there, so it can be considered as square matrix. And here same elements should be there, that will be scalar matrix. Identity matrix is also same thing, but just one should be there, not any non-zero number, not just any same number, exactly one, and it should be a same number. So this is a kind of scalar matrix because same number is there throughout. It is a kind of diagonal matrix because other elements are 0. It is a square matrix, but again it is identity matrix because 1 is written. So here you will tell it's a identity matrix only if 1 is written. If 4 or 3 is written, you can simply call it as diagonal or scalar matrix. So that's it. All these things should be square matrix. Only diagonal elements should be non-zero, rest all elements should be 0. If you can just see that they are different ones, just diagonal matrix. If they're all same, then it will be scalar matrix. If they're all 1, then it is called identity matrix. Next one is a very simple one, zero matrix, when all elements are 0. Zero matrix or null matrix. And it is not specific that this should be a square matrix only. It can be any matrix, it can be rectangular also. Rows and columns need not be equal over here. And zero matrix meaning wherever they give O, that means it is representing zero matrix. Next, equality of matrices. This is important. They are of same order. See, at first itself, if they are talking about two matrices, you have to check if order is same or not. 2 rows, 3 columns or not. If this is 2 rows, if this is 2 rows and 2 columns, if they're equating with some other matrix, see if that is also having 2 rows and 2 columns or not. Otherwise, it's never going to be equal. Then corresponding element should be equal. Here 2 is there, so here 2 will be there. Here 3 is there, here 3 will be there. Like that. So if I immediately write something like this, suppose here A, B, C and D, and I tell there is some other matrix A, B, C, D, E, F. Immediately by seeing it, if they're asking are they equal or not, like sometimes they give equations over here for you to solve and find the values. If they immediately they're asking is there any way this could be equal or not, you can immediately say that okay, this is 2 rows 2 columns, but this is 2 rows 3 columns, order is not same, so there is no way that these two could be equal. So first important point, always check the order, and then the corresponding elements should be equal. Suppose if I just write this as one matrix, then okay, this could still be equal if A is equal to B. If A is equal to A, B should be equal to B, C should be equal to D, and D should be equal to E. If this is the scenario, then I can say two matrices are equal. So they give like this questions generally. Here they might even give complicated by saying x square plus y and all that, where they will make you solve linear equations or quadratic. But yeah, this is the simplest one. So here you're able to see, okay, 3 rows 2 columns, 3 rows 2 columns, okay, these could be equal, and if they're equal, their corresponding elements should be same. So first element should be same, so x should be minus 1.5, y should be 0, z should be 2, a should be root 6, B should be 3, and C should be 2. So like this kind of questions they generally give, saying that okay, x plus 3 is 0. First check 3 rows and 3 columns, 3 rows and 3 columns. Don't think that this should be like equal number of rows and columns, square matrix only. Any kind of matrix they can give on both the sides, any order can be there, but that order should be same. Now because they already gave the equal to sign, you can directly equate. X plus 3 is 0, z plus 4 is 6, and 2y minus 7 will be 3y minus 2, and then minus 6 and minus 6 already is there, so a minus 1 is minus 3, then 0 is 2c plus 2, and b minus 3 will be same as 2b plus 4, minus 21 and 0, already those elements are there. So you can find out the values now. X is nothing but what? If you send it over here, it will become minus 3. What will z be? Send this 4 over this side, it will become 2. And you can send 2y this side and minus 2 over here. Minus 2 will become plus 2. Then 7 minus 2 will become minus 5. If 2y is going over here, 3y minus 2y will become y. Simple, normal equations only. If you send minus 1 over here, minus 3 plus 1 will become minus 2. Then C. Here minus 2 divided by 2 will become minus 1. Then B also you can send it over here. 4 can be brought over here. Minus 4 minus 3. It is nothing but going to become minus 7. And if B is going this side, 2B minus B will be 1B. So simply you can rearrange and find out the values. Here also one more question is there. 2A plus B, already they gave the equal to sign, and 2 rows 2 columns, 2 rows 2 columns are there, so not an issue. You can see the corresponding equations. 2A plus B is 4, then A minus 2B will be minus 3, 5C minus D will be 11, 4C plus 3D will be 24. So how can you solve this over here? You can multiply this equation with 2. Let me just write it down to solve it. Yeah, so over here you can multiply with this 2, then it will become 2A minus 4B is equal to minus 6. Then what is our first equation? 2A plus B will be equal to 4. Now we can subtract these both. If you're going to subtract 2A minus 2A will get cancelled. Minus 4B minus B will become minus 5B, and you're subtracting it, so the signs will change. This will become minus, this will become minus, right? So then minus minus will become you have to add, so it is minus 10. B is here, minus 5 will be gone over here, so minus 5 into 2. So minus minus sign can be cancelled and B will be 2. 5 2s are 10. Now after finding out B value is 2, you can find out A value, because if B is 2, then you can send the 2 over here, then it will be 4 minus 2, then A should be 1. Now similarly C and D value also we can solve. I am able to see 3D over here, so I can simply multiply this equation with 3. So 5 3s are 15C, then minus 3D is equal to 33. Then 4C plus 3D is equal to 24. Now here already minus sign I got, that's why I can directly cancel it off. That means I'm adding them. So this will be, no, it will be 19C being equal to 57. So C value will be 3. 19 3 so 57. C value will be 3. Now you can put it in this equation. 15 minus D is equal to 15, because C value is 3. 5 3s are 15. Then D value we need is equal to 11. If we simply subtract 15 minus 11, send D over here, then D value will be 4. So we got A value 1 and B value as 2. B is 2, A is 1, C is 3 and D is 4. So this was for the intro part and solving the examples. In my next video, I will solve this exercise. If you like this way of teaching, please like the video, and you have any doubts and any problems to solve, you feel free to leave comment in the comment section, and please subscribe guys. Thank you. See you in the next video. Bye.